Good day, good day, good day. On this lesson, I'll be doing Agric paper 1 from November 2023. So it was a national paper for the class of 2023. So without wasting any time, I'm going to go straight to the questions. So the first question is a multiple choice question. So we know we were given four options and we must choose the correct possible answer. So on the first one, 1.1.1, one of the following is not part of the four stomach components of a ruminant. Okay, so this type of question, you need to know all the components which are there in a ruminant. So if you know all the four parts which are gonna be there, it allows you to figure out which one can be the possible answer here. So we know we've got four components which are there in a ruminant, and all the four given options are part of the four compartments of a ruminant. We know we've got the rumen, we've got an omasum, we've got an abomasum, and reticulum. So all four of them are components in a reticulum. So now you just need to know that the only true stomach that is there in a ruminant is abomasum. So we call abomasum a true stomach. So here they're asking, it's not part of the four stomach. So abomasum is a true stomach. So meaning it won't be part of the four stomach because it's a what? It's a true stomach. So meaning option D will be the correct answer because abomasum is a true stomach, meaning it's not a four stomach because it's a what? It's a true stomach. So C will be the possible answer. But all four of them are components of a ruminant. But abomasum is a true stomach, not a four stomach. 1.1.2, an example of protein rich concentrate. Okay, you just need to know from the given four which one is rich in protein. So you need to know all of them, the ones which are rich in protein, the ones which are rich in carbohydrates as well. So the one that we know is rich in protein is the carcass meal. Carcass meal is very rich in protein, so it will be D there. It's very rich in protein, carcass. And then tubular indentations of epithelium between the villi that secretes sulcus and tegrus. So here are in the intestines. So you just need to know the components in the intestines, things like the enzymes or everything that will assist the intestines to digest food. Because the aim of the intestines is to absorb all the food. So you need to find out what is there in the villi. And once you do the diagram of villi, you can figure out which one will be that. So from the given options here, we're given a set of ligaments, pancreatic glands. So pancreatic glands, so given glands of Lieberkühn, and then also bile duct. So the one that secretes suckers is the glands of Lieberkühn. The secret suckers, so it's the glands of Lieberkühn. That will be that. So without wasting time, let's move on. 1.1.4, a nutritive ratio of 1:4 implies that, okay, first option, the feed has high protein content. Okay, so let's just take them one by one. So they're saying 1:4 ratio implies that the feed has high protein content. Yes, that's true. The feed is suitable for growth and reproduction. Yes, because it has got protein. Okay, that's fine. For every one cup of carbohydrates, there are four parts of protein. No, that's not true. Okay, for every one part of protein, there are four nitrogenous non-compounds. That's true. So it's for every one of protein, there are those four parts which are non-nitrogenous species. So 3 is not correct. So it means it must be Roman figure 1, Roman figure 2, and Roman figure 4, which is option D, which has got that combination. Option D has that combination of 1, 2, and 4. Okay, a farmer producing crops of livestock to generate profit using highly advanced techniques, technologies. So just basically they want us to figure out definitions. What type of farmer does that? So the one that uses crops to profit is the commercial farmer, because you know with commercial and profit they go together. So commercial and profit they go together. 1.1.6, the following The following are requirements for an ideal poultry housing facility. Okay, again, let's tick the ones which are gonna be correct for ideal poultry housing. Length orientation should be north south direction. Yes, that is true. Okay. The roof must be high and insulated. Yes, the roof must be high. That's fine. Side walls should keep running water away from the house. Yes. Side walls should not. It's opposite of that other one. So if the other one says yes, the other one will be no. So meaning 4 is out because it should run away from the house. So meaning 4 is out. So the correct option must have from figure 1, 2, and 3. 1, 2, and 3 is option A. Fine. Okay. The microscopic organisms that live outside the body of a host, which cause the twisted skin, leading to loss of wool. So we know if you're dealing with a sheep, it can lead to a loss of wool. So it's dealing with the sheep. So most of the organisms which live outside, it's mostly get those ticks. You've got different type of ticks, which they'll undergo different cycles. So basically here you find the one which will be linked to the cause of a wool. So it's not the ticks, it's the mites. Yeah, the mites are the ones that are linked to sheep. So most of the loss of wool in the sheep is due to the mites. The mites are the ones who will be causing that symptom. 1.1.8. One of the following is not a sign of poor health in farm animals. Okay, sorry, sign. So the same is not a sign. So basically, we need to find the signs of that. We need to find the signs of that. So the signs of that, rough, yes, that's a sign of that. Tough, too soft, yes, it's a sign of that. Bright eyes with pink, nope, that's not for animal. High blood pressure increase, yes. So the one that is not correct or symptom of that is C. C is not part of the symptoms. Okay. Okay. A sign of a cow approaching a pasturation is what? So that will be that. For D, it won't sniff because that's for um heat. That's also for heat. Also when it's around the heat, so it will urinate a lot. The last one, yes, I saw that I was not recording, so the last one would be B because these ones are for fertility or for castrations. So meaning number D would be B, then 9 would be D. Let's quickly move on to 1.2 now. So 1.2, so we're given A only, B only, both, or none. So you need to match them. Column A has got bile and also liver. So column B is the breakdown fats into fine droplets. So that is done by bile. So bile will drop those fats into fine droplets, meaning it will be A only. So here it's going to give us A only because it will be bile that will do that. So it's going to be A only. So that will be A only because bile will do that. So it will give us A only there. Okay. An organ that helps farm animals to distinguish between different feeds. Yeah, remember for tasting will be tongue. Tongue is there for tasting. So tongue should be the organ, should be B only. Because tongue will be there to allow them to taste different feeds. So it will be B only then. Because tongue will be there to allow them to taste different feeds. Okay. 1.2.3. The ability of a farm animal to maintain a constant body temperature. That is homeothermic. That is homeothermic, which is B only. That is homeothermic, which is B only. Going to maintain a body temperature. That's B only homeothermic. And then a poisonous plant that should be prevented by avoiding storing feeds under wet conditions. Yeah, thorn apple. No, that's not even any of them. So it's not any of those. So that will be that. So it will be 9. It's gonna be 9 for that. to 9 because it won't be any of those, it should be 9. Okay, 1.2.5 hormones used in synchronizing oestrus in cows. So for those ones who are doing also life science, you know that mostly we can link that to estrogen, but here we've got these two hormones, which is prostaglandin and progesterone. So both are used to assist in oestrus. So it'll be both A and B. For both of them, they are used, those two hormones, to assist in oestrus. So it'll be both A and B. Because those both hormones are there. Mostly for life science, you think about estrogen and your LH and your FSH, for those who are doing life science as well. So it'll be both A and B. So 1.3.1, now we are doing our biological terms. So one word for each. 1.3.1, the enzyme that breaks down starch molecules in pigs. Enzyme that does that is amylase. That's amylase that does that. So it's going to be amylase that does that. Amylase is the one that will be the enzyme to break that amylase. So it's all about knowing all the enzymes and their functions. So it will be amylase there. The small area where sheep are kept under intensive conditions and fed for maximum production. That's a feedlot. So even cows, you can put them in a feedlot. So mostly when you put animals or want to put them in a feedlot, especially the ones that we have in the farm, or yeah, mostly in the farm, the feedlot. Okay, a reproductive technique where semen is collected from a superior bull and then is deposited in the cow. We call that artificial insemination, or AI. It's called artificial insemination, or in short, we just call it AI, artificial insemination, or AI. So it's artificial insemination, or AI. Cows that need to mate 3 or more times before conceiving, we call those repeat breeders, because they need to take a lot of mating. We call them repeat breeders. They're called repeat breeders, those ones. We call them repeat breeders now, because they need to mate a lot of times before they can conceive. We call them repeat breeders. Repeat breeders now. I'm just going to squeeze it there, repeat breeders. Okay. The inability of a bull to service cows that are in estrogen, even though it has interest, we call that impotence. It's important when you have interest but you can't, so we call it impotent. It's important, but they've got interest but they can't service those bulls. We call it impotent. But they've got interest but they can't do that. It's called impotent. So for life science, mostly you've got those particular terms for 1 mark. So for agric, they make them 2 mark each, which is a good thing. 1.4 now. So now we just need to change the word which is underlined. Okay. Digestible is underlined. Then its energy refers to the energy left after deducing energy lost through the heat from metabolic. That's net energy. It's net energy, that one. So meaning we're going to change that digestible to become net energy, because that's net energy. Okay. The introduction of natural enemies to control parasite infection is the same chemical. Mostly we know either it's chemical or biological. So to be biological method. So mostly we use chemical or biological methods. So if tomorrow they were to give you biological one, it's bound that you're going to be changed to chemical one, because mostly the most common two methods for parasite control. The central resists an enzyme that assists the sperm to penetrate the ovum. It's not central, it's an acrosome. So you need to know the head of a sperm. So you need to know the head of a sperm and just know all the functions of the sperm, the tail, the head, and all that. So acrosome is the one that will have enzymes which will penetrate the ovum. Di-oestrus happens when sexually mature animals start to. So we've got di and also ano. So ano is the one that will occur when sexual women, sexual females, or oestrus. So it's ano oestrus. We've got di and ano. So it's going to be ano, this one. Ano oestrus now. Okay. Gestation refers to the period in cows between to lactation, that's dry. Gestation is when it's giving birth, so that's dry. Gestation is when it's pregnant, so this one is dry. Gestation is when it's pregnant, so this one will be dry. Okay, now let's go to 2.1. Now we're in animal nutrition. So we're given our picture of a canal of a sheep. So we know a sheep. We need to first know whether it will be a ruminant or a non-ruminant. Yeah, and then now we are given different labelings, which I always advise label first before you do the questions. 2.1.1, identify the picture above, only the letter of the part where each of the following occurs. So they want us to identify in the diagram where each of the following occurs. Okay, so first, identify the above diagram letter of the part. Okay, so they want us to find the letter of the part where each is occurring. So basically, they want us to find the letter of that. Okay, microbial fermentation will occur in B, or B or C. Yes, maybe in B. You can have it in B then. Mechanical digestion, it's mostly going to be in A, and then because it's a ruminant, you can also have it in F. It can also be in F, where it's especially at night when it's chewing the cud. And then lastly, we've got chemical digestion. It can occur in the either. It should be either. It should be the part, or it can be D. You can also have it in D, because D will be towards the end of the stomach. There. Yeah, that should be that. Okay. 2.1.2, name function, one function of small intestine. So no, it's what? It can absorb all the digested food. So one function can absorb all the digested food. So that's the purpose of it. Sometimes it also secretes juice, which can also break down other food, or it can digest all the digested food. It can be any function of the small intestine. You can list maybe 5 or 6, but I just want one. I just want one. 2.1.3, compare the structure of esophagus in sheep. Compare the structure of the esophagus in sheep or with that of a fowl. Fowl will be the chicken. So that call us to compare the esophagus of a sheep and the one of a cow. So we know the one of sheep is wide. So the first thing that you can notice that the one of a sheep is what? Is wide. So you don't have to compare. The one of a sheep is wide. That can be the first point. The one of a sheep is what? Is wide. So and then the one of a fowl is narrow. That's the difference. If one is wide, the other one becomes narrow. So mean the one of a fowl will be narrow. That's one thing that you can compare in terms of esophagus. The one of a sheep is wide. The one of a fowl is narrow. That's like one difference to compare the esophagus of each. You're now given a paragraph. The biological value of protein is determined by the amino acid composition and some other factors. Animals need amino acid that their bodies cannot produce, but in ruminant animals that produce quality of feeds is of less importance. Then 2.1, give the collective name for the amino acid that can not be produced by the body. We call them essential amino acid. We call them essential amino acid. Essential amino acid. We call them essential amino acid. They can be produced by animal bodies. We call them essential amino acids. They're essential amino acid. We're going to call it essential AA, which is amino acid. Explain why the protein quality of feeds in ruminant animals is of less importance. Okay, less of importance. Okay, we know that of ruminant animals. Okay, we know that microorganisms, I'll just call them MO. So microorganisms that are there in the ruminant, they can utilize amino acid. Microorganisms in ruminant, they utilize amino acid, or they can make use of amino acid. So they utilize amino acid, which is AA. So they utilize amino acid. Those microorganisms which are there. So when they utilize amino acid, this means that we can be able to synthesize. So to synthesize, just call it synthesize. So doing that, it will allow them to synthesize microbial protein. So they'll synthesize what we call microbial protein. So we're able to synthesize what we call microbial protein. So we're able to synthesize microbial protein. So microbial protein. We're able to synthesize the microbial protein. Protein. Okay. So yeah, that is why the protein quality feeds is of importance, because they can synthesize the microbial protein, which has a higher biological value. So it is easy if you to explain that, you say that the microorganisms in the ruminant, they can utilize amino acids to synthesize microbial proteins which have higher biological value. So with higher biological value, just called it with higher error higher biological value, which is BV. 2.2.2 now. An ox was fed 24 kg dry matter and excreted 7 kg manure with 80% of dry matter. Calculate the digestive coefficient of the feed. Show all the calculations. Okay. So first thing first, for 2.3, you just need to find the DM first. So just find the DM of the manure first. DM of the manure first. We're given 81%. The DM of the manure, we know that 81% is the same thing as 80 over 100, or 0.81. So just use 81 over 100, and then you multiply the DM of the manure, you multiply that by the kg of manure, which is 7. So 81% of the 7 of manure, which we have here, is 7. So 81% of 7, let's find that 81% of 7, which is 81 over 100 times 7. Okay, I'm getting 5,67, which will be in kg. So basically the DM of manure will be, we're using kg units, so it will be 5,67 as kg units there. That's fine. Now to find the digest stability coefficient, which is DC, just called DC now. So DC, we know the formula we know is dry matter intake. So it's dry matter intake now. DM intake, which is dry matter intake, and then you will minus it that by dry mass of manure. So this is DM of manure, which also will be in kg, and then you multiply that the whole thing. So you multiply that whole thing there by 100. So you multiply that whole thing by 100 there. So you multiply that whole thing by 100, and then you will divide that by dry mass intake, which is DMI intake, and everything is in kg as given to us now. Okay, so dry mass intake, we're given dry mass intake as 24. So dry mass intake we're given as 24, so that will be 24 there, and then minus dry mass of manure, which we just found as 5,67, which you found as 5,67, and then the whole thing you will divide that by dry mass intake, which we know is given to us as 24 now. And then from there you will multiply that whole thing by 100 from the formula, and everything is in kg, so you will have to convert the units to other units. So just put everything as it is, find the value. 24 minus 5,67 over 24, then times 100. It's a high percentage, which is 76. I'll put into decimal now, 76.38%. So 76.38%, that should be your DC. 76.38% is your DC. That's fine. So now let's go to 2.4. We're given components of a feed. Okay, fine. So feed is having dry matter, water, organic components. There's A, which is missing, then there's B there, the P is vitamin, the C, and also maltose. Okay, so now we're asked to find the values of component A first. A is this one. So A is inorganic components now, because we've got organic ones here. The other one will become inorganic components, because we've got organic and inorganic. So meaning just the inorganic components here. So the other one is organic there, and so it just becomes inorganic components. That's fine there. So it will be inorganic components there. inorganic components there. Okay, fine. Then that has to find A and C. Okay, A and C. Where you see C is giving us maltose, and we get maltose from carbohydrates. So we get maltose from carbohydrates. So C is giving us that. So meaning B will be proteins. Okay, that's fine. So we get maltose from carbohydrates. So that will be carbohydrates because we get maltose from carbohydrates. So it's good to know your monosaccharides, your disaccharides, and your polysaccharides. So you know maltose is from carbohydrates. That's fine. State two functions of water. Okay, water, it helps to moist the food. Ne? It helps to soften the food. That's something that water does. It transports nutrients. It can also eliminate waste product. It can also flush out waste in the body. Water. So it can moisten the food. It can transport the food in the body. It can assist in milk production. So a lot of functions of water. You just want to have two. Ne? So you can say it moistens the food. It helps to transport the food in the body. It assists in milk production. It also acts as a lubricant. So it can be any of those two functions. 2.4.3, write down the letter that represents the component suitable for feeding young animals to grow. So for young animals, it can't be these ones. These ones, no, they can't be for young animals. Young animal is B. So whatever the B is for young animals. Then has to put the letter. Yeah, the letter is B. They don't have to say the name. Okay, it's fine. It will be proteins, but because they don't want the letter, we just say the letter, which is B. Which I think they're fair to us. In case if you don't know what B was. Okay. 2.5. A farmer mixed soya bean, olive cake meal, and oat with the ratio of the desired protein content. Okay, let's feed DP the parts and all that. Okay. 2.5.1. Refer to the percent square above to indicate the ratio above that represent each of the following. The soya oil cake meal first. Okay. So then that's to find how much the soya oil cake meal will be. So we've got 10%, 29 parts, 44%, and then 6 parts. Yeah, that will be 6. So the soya meal will be 6. And then meaning if soya is 6, then oat will be 29. Yeah. So it's a farmer mixing soya bean. So the farmer is mixing soya bean and oatmeal to the ratio below. So 9% will be, this one will be for oatmeal, and then this one becomes for soya bean. Okay. Calculate the percentage of oatmeal in the given mixture hour. Okay, so we know that for oatmeal we've got 29. So it'll be 29 plus 6, that'll give us 35 now. So overall we've got 35 parts. For those two, when you add them, they'll give us 35 parts. So we have 35 parts overall based on soya and oat. So we've got 35 parts all together there. That's fine. So they want us to find the percentage. Okay, so it'll be 29 over 35 times 100 there, because it's percentage. 29 over 35, then times 100 times 100, because it's percentage. 29 over that times 100, because it's percentage, and then let's find that out. 29 over 35 times 100. When I put two decimal again, I'm getting a huge percentage. 82,86. 82,86%. That's a huge percentage. 82,86 percent. That's a huge percentage. That's fine. Okay. 2.6. The table below shows a further blog program on the provision and the feed requirements of beef cattle over a year. Okay. And then 2.6.1. Calculate the quantity of feed in kg during the first 6 months of the year. Okay. So that has to find for the first 6 months of the year. So it's going to be from January, February, March, April, May, and June. The first 6 months. So it's from January to June, the first 6 months. Okay, let's see the quantity of feed for those. So we're given the values there. So it's gonna be those values there. It's 50 for January, February is 50, March is 50, then 55. Just need to go and add those values. So it'll be 50 plus 50 which will be 100, and then plus 50 again, which will be 150. That's for March now. Now we go to April, is also 50, and then we go to June. This one May is 55, and then we go to June, which is 60, based on the table now. So these are the values that we're getting there in the required one. So let's add this and see how much we're gonna have. And the unit, is it kg? No, it's ton. We're using ton now. So let's add those 50, 100, 150, 200, 255, and then 315. So it's 315. When you add those values, then it's ton. Just not we just ton. Yeah, okay. Just use the unit of ton. I use it capital letter, just call it ton once. Yeah, just call it ton. Just put that negative sign there. Because my select the negative sign. Okay, it's fine. So it's 315 ton, which is the value we're getting in ton. And then they want us to find the quantity of it. Okay. So the overall that we're getting here, how much will that be? Because it must be in kg, and we're in ton here. So in ton it's fine, but because we're in kg, so we know that 1 ton is equals to 1000 kg. So to go to kg now, we need to multiply by 1000, because the one that's the answer in kg. But if the answer was in ton, we're done. But because the answer must be in kg, let's multiply by 1000. But if tomorrow to give us the everything in kg, and then the answer must be in ton, we'll divide by 1000 when you're going backwards. So it will be that times 1000, which just give us 315,000 kg, which will be that in kg. That will be that in kg. But if it was in ton, we will fine. But because it must be in kg, just convert kg to ton. Give two reasons why the folder flow planning is important. Because it allows us to safe use our resources. That's the first point you can say. It allows us to safe use our resources. It also allows us to ensures a positive margin over the cost. So the second part will be, it also allows us to have a positive margin over the feed cost. The second part you can say. Also, it allows us to meet animal feed requirements. So those are the 3 points you can say. Allows us to meet the feed animal requirements. It's for safe use of resources, or you can say that it ensures positive margin over feed cost. There's 3 points that you can use. Okay, for 2.6.3 is the graph now. You want us to draw the graph for the beef cattle production of Ukraine from August to December. So from August to December, we learn to use August to December is this partner. Just be careful of that. It must be from that. So just want to show you guys how the graph will look. First of all, you must have a heading or the title. Title must be there. It can be anything linked to this. You can just come and copy this, for example, or you can just come and copy the last part in the question. This last part of the question as your heading. Just come and copy it as it is as your title for the graph. Then you must have y and x. So y, it will be the quantities in tons. So it will be quantities in tons. It will be the quantities in tons, which is the quantities, and the unit must be in ton, because we're dealing in ton. And then here we know it's going to be month of the year. So it will be month of the year here. On the x-axis will be month of the year. And then you must put August, month of the year. So you'll put August and then September until you put December, then the last one. Then just go and put the values as they are. So remember, it's from November to December. So that will be that. Yeah, just put the title, the Y labeling, also the X, and then get the correct scale. Also the correct scale, and then it's a line. Yeah, it's a line graph. It's a line graph. So the line graph will look like dots. It must have dots. Must have dots as a line graph. Must have dots. Then you just join the dots depending on how the points are going. Those two things there. Then that will be a line graph for 6 months. So when they mark you, they mark for y and x axis, the title, and the correct plot if you're doing them correct. Okay, let's go to question number 3 now, which is animal production, protection, and also control. Now. So given two pictures here, picture A and also picture B. And then in A, the production system used by the pig farmer, represented by picture A, shows, so they want us to say what picture A is showing there. So that's an intensive production system. We call that an intensive production system, or IPS. It's called intensive production system, which is IPS. And then B is, we call that free range system, which is FRS. It's free range system. So here there's intensive protection or production system. Here it's free range, where the animals can just move around freely. 3.1.2, identify the animal handling facility in picture A. This is one picture A there. So the animal there ending that is shown there, we call that a farrowing pen. It's called a farrowing pen. It's a farrowing pen. We call it a farrowing pen. Give one reason for housing pigs in A. So the reason why we are having pigs there for A is it allows us to have easy management of them. So we can have easy management of the pigs. That's one reason you can say. It just allows us to have easy management of the pigs. So the reason why we're having pigs in A is because it allows us to have easy management of pigs. That's for 3.1.3. We can have easy management of the pigs. 3.1.4, deduce two factors from picture A that contribute to increased production. Okay, reason that will contribute to is production is, remember, we are controlling this management. So whenever you've got management, that can increase production. So we've got management can increase production. There's management there which will assist production management. So it's one of the factors which will assist in increased production, which is management. And also there's feeding, because now they're being controlled. So when you feed what they eat, so when you're feeding them, meaning you can feed them what you want them to eat, and then they'll grow better, and then you can be able to have an increased production. So it's feeding. So those are the two factors that can contribute to that going up. 3.2 now, choose an extension from the list that matches animal behavior. Okay. In questions 3.2.1, write only A to E in the next question. Okay, fine. So 3.2.1, female animals in the herd mount other females and allow them to mount them. So what's that? Is that shadow passion? No. Normal maternal behavior? No. Normal animal behavior? No. Normal reproductive behavior? Yeah, that's normal reproductive behavior. A flock of farm animals look healthy and graze on natural pasture. Okay, that's normal animal behavior. Yes, just put it down quickly. Okay. Animals head butting each other. So that's when they are looking for a mate. Most when animals are looking for a mate, they can fight or show some strength that they have. So that's what we call animals establishing their dominance. So that'll be dominance. So they're fighting for to show that I'm stronger than other one, than to attract a mate or get someone to be impressed by them. 3.2.4, animals do not want to enter the gate leading to the passage area. So yeah, it's fishing area. So that's gonna be fishing area, which is the first one. Fishing area. So now that I've done everything, it leaves us with B. B is the remaining one. Normal maternal behavior. Let's say animal became, yeah, after birth. Birth is maternal behavior. So that will be B. So the good thing to target, you can target this one, maternal. That's birth. You can target also area, which is A. So there's two ways to spot, even if you don't know what's happening. Same as this one, where they're fighting is dominant. So that's three. Once you can get them, then you can just go and look for first two, or two, which one will be which. 3.3 now. Identify the facilities A and B above. A is this one. So that's A there. Okay. So they want us to find that A, we know the crash. That's a crash. Not the crash that most of us in high schools used to have or have. The crash that they use for animals there. And then that's a head gate. B is a head gate there. So B is a head gate. There is a head gate. So B is a head gate. Even it's showing that it's a head gate. The animal is taking out its head. It's a head gate. So the animal is showing out its head. It's a head gate there. Okay, fine. Indicate the purpose of facility B. that is to restrain the animal. To restrain the animal. So you want the animal to be controlled or restrained. That is to restrain the animal. To restrain animal. That is to restrain the animal. Give two reasons for handling farm animals using facilities above. So of course it's management again. Management practices. So called MP. It's management practices. That's why you're handling them like that. Is to have management practices. And also you need to transport them. So for transportation, because you need to transport them. That is for transportation. Also it's for data, to get data. For us to get data, there you need to have that type of control. So you can say for management practices, you can say for transportation, for getting data, for finding the age of the animal, for testing pregnancy, any of those reasons will be linked to that. Then 3.4, state two basic requirements for transporting animals. So two requirements. So if you're transporting animals, every car that's transporting must have a red flag. I think the same thing applies when you're transporting like things like quadrops, your bears and all that. Every car must have a red flag behind. Same thing applies when you're transporting animals. The vehicle must have a red flag behind. And then also don't have sharp edges. Don't have sharp edges because they can hurt the animal's sharp edges. Don't have sharp edges because they can hurt the animal. Of course, if you're transporting something, you must have legal documents which are correct. You must have legal documents which are correct. So anything that those lines, you can have legal documents which are correct, don't have sharp edges, you have a red flag behind the car, and then the floors you're using must be nice. Don't have floors which are slippery because the cows and the animals must be standing still. Don't have floors which are slippery for them. 3.5, a mosquito-borne viral disease that affects sheep, cattle, and goats causes abortion, blood-stained nasal discharges, and diarrhea, which may lead to death of farm animals. People can get infected if they handle blood, tissues, or other body fluids of animals that are infected with the disease. Okay. Farmers should alert authorities if they suspect that animals are infected with the disease on their farms. Okay. Name the disease described in the above. Yeah, it's what we call the Rift Valley fever. It's the Rift Valley fever, or the RVF. It's the Rift Valley fever, the RVF. It's a mosquito disease. It's the Rift Valley fever, or the RVF. Identify an example in of the following above scenario. A vector. So vector that is there, it's a mosquito. Mosquito is the vector. That's the vector. It's a mosquito. That is the vector. Then the pathogen. Pathogen is the virus. So pathogen is the virus. Mosquito is the vector, and then the pathogen is the virus. The disease in the scenario above is deemed not fiable. Justify the statements. It's highly transmissible. It's also highly infectious. The reason why it's only because it's highly infectious. It's highly infectious. That's why it's deemed interferable. Because it's highly infectious. That's why it's deemed interferable. Highly infectious. That's why it's deemed interferable because it's highly infectious. That's why it's deemed like that. Highly infectious. I repeat that. Highly infectious. Okay. 3.4, 5.4. Give the term for the description which indicates that the disease can infect people if they handle infected blood, tissues, and other body parts. So the term for that is zoonotic. We call that zoonotic. We call that zoonotic. If someone can touch the blood and get that, we call that zoonotic. It's zoonotic. Okay, how's that? Okay. Suggest two economic implications of animal disease to a farm. Okay, guys, if a disease is affecting you in a farmer, that's a dangerous tool. So one thing that you know, you're gonna lose income. That's one thing that you must know. Be loss of income because you're losing an animal. So if you're selling 5 cows and they're all sick, so therefore you can't sell them anymore. That's losing income. Also, you'll be losing your stock because they'll die, those animals. So you're losing income at the same time, you lose your stock because they're gonna die, those animals. And also, some if you want to cure them, medication is very expensive. So you need to spend a lot of money to get medication. So any of those three things can be part of your answer. As long as you're on those lines, you can be costly because you need to get medication, they're gonna die, you lose livestock money. Yeah, any of those factors will be detrimental to you as a farmer. 3.6, the diagram below shows the life cycle of a parasite. Okay, so you have a parasite now, showing a tick, going to a cow, then it comes back, it goes to a rabbit there. Okay, classify the parasite above according to life cycle. It's going to a cow, then it goes to a rabbit, so it's a two host. If it's only a cow, it would be one host, but because there are two animals involved, it's a two host there, because there's a cow and also a rabbit. So it's a two host. We call it a two host life cycle there. And then give a reason, it needs two hosts. It needs two hosts. So this animal, this tick needs two hosts to survive. So it needs two hosts to survive. That's why it's a two host life cycle. It needs two hosts, which is this one and that one. So it needs two hosts to survive. So the two hosts, but it needs two hosts to survive. 2.6.3, identify three stages in the life cycle above. So three stages, we know, okay, three stages. We've got the adult. That will be the first one. You can have adult, and then you can have X, and then you can have larvae there, and then you're gonna have lamp. So they want three stages. So you can say adult, that's one stage, and then you've got X, second stage, then you've got larvae, third stage, the fourth one will be the lamp. So those are the four stages you have. So they just want three stages here to put. So three stages they will be, you can have adult, then you have X, then you have larvae as your three stages. Or you can add lamp as the fourth one, but only one three, which they are there in the diagram. Below is an internal parasite that affects animals, farm animals. Okay, choose the parasite that matches each of the following descriptions. Okay, cause nodules in the liver. The one that causes nodules in the liver is the liver fluke. It's in the liver, so the liver fluke. So it's a giveaway also. It causes nodule in the liver. So liver fluke because they're in the liver. So liver fluke will be there in the liver. It's this one. Liver fluke stay in the liver. It's liver fluke. Okay. Does not need an intermediate host. That's a roundworm. Roundworm does not need an intermediate host. That's a roundworm. So meaning the last one is a tapeworm. But just see. Heavy infestation causes a pot belly and the appearance of that in feces. Yes, it's in feces tapeworm. That will be tapeworm. Okay. State two basic principles of good health that a farmer can apply to control um, parasites. Okay, you can do vaccination. Vaccination helps to control the parasites. So you can do vaccination. It helps to control the parasites. Also, you have good hygiene. If your farm is not looking nice, it will cause a lot of parasites there. Have good hygiene. It applies to us human beings as well. Have good hygiene. If you've got a good hygiene, you can avoid such parasites there. Good hygiene, vaccination, you must have proper feeding, anything that will allow your farm to run nice without attracting parasites or microorganisms. So now we're going to animal reproduction, which I think is also a good topic for those who are doing life science, because also in life science, you do reproductions, which allows it life to become a bit easier now. So they want us to find labeling for B, C, and J. B is this one here. That's our B there. So B is a sperm duct. So that's B. B is a sperm duct. Just call it a sperm duct ST. It's a sperm duct B. That's B. It's a sperm duct. And then C, where you see? C now we're going inside that part there on top of the testes. So it's epididymis, that one. That is epididymis. It's epididymis, that part there. It's epididymis. It's that part there which temporarily stores sperms there when they're maturing. Oh, so yeah, that's epididymis. At top of the testes there, epididymis. And then J, where are you? Oh, J is that part. Okay, C is epididymis. Now let's go and find J. J is this part there. That part there, now it's in a female. It's a cervix. It's a cervix there. It's a cervix in the female there. Cervix. Okay, that's fine. Okay. Identify letters Letters A to I in the diagram 1 and 2, which each of the following occurs. Okay. Site where spermatogenesis occurs. We know that occurs in the testes, and testes is letter D. That's D. Okay. Saves the functions of implantation. So implantation, now we know we're going to the female one, which will be E. E, that's where you can have a implantation occurring. That's E. Site where fertilization occurs. Fertilization will occur. You know that you need to move around that part there, which will be I. So it will be I there. It will be fertilization occurring. Secretes a sticky liquid that provides energy for the sperm. Now we are back to the male one. So it's a gland. So the gland that produces that is gland A. So it will be gland A. So that's A, where that gland will produce the energy for sperms. Okay, so now let's go to this. The picture below shows a cow and a bull during a process. So identify the process above. That's mating. We call that mating. So they're mating, those two. So that's called mating process. It's a mating process where they are mating. It's a mating process. 4.2.2 indicate the actual stage of the process. 4.1, which results in that it's mounting. The mounting is called mounting. It's a stage called mounting. So it's mounting. So it's mounting. Okay. And then 4.2.3, state 2 sexual behavior signs that are displayed by bulls before the process. So mostly when they are about to do that, they protect the females in ostrus. So they'll protect the females in ostrus, and then you're going to have a swelling that they'll be showing swelling in their genitals. They'll be showing swelling in the genitals, and then also they start snorting or hitting the ground a lot. Yeah. State 2 factors that regulate the actions in both, which I shown before. So the factors that will regulate that is genetics. So the how the ball is undergoing, like how its DNA controls it, it will affect it. So the first factor you can say is genetics. Genetics will play a good role in that. Also hormones, the influence of hormones will also influence that. Also feeding, the type of food they're eating will also influence that. Same as the health status. So you can list any of those four. They're the factors that will contribute to the bull's mating. 4.3, the systematic representation to below illustrate the process in farm animals. Okay. So there's reproductive techniques, nucleus containing DNA is taken, then blastocyte is in the recipient, and then there's embryonic sperms there. That's cloning. So you just know that this is cloning there. So whatever is happening is cloning here. 4.3.1, that the type of reproductive technique which is shown by A and B. So A is this one. So A is what we call reproductive cloning. So A is reproductive cloning, and then B is stereotypic cloning. So we've got reproductive cloning here, and then stereotypic cloning. That's A and B. A is reproductive cloning, which is reproductive cloning. It's called there. It's the reproductive cloning. Reproductive cloning. Reproductive cloning. That's A there. Reproductive, and then B is therapeutic. Reproductive, and then B is therapeutic. Therapeutic, then therapeutic, which is B. Therapeutic, yeah, therapeutic cloning. The two types of cloning which you are seeing the therapeutic. Okay, that's fine. Identify the purpose of each of the reproductive techniques above. So the reproductive one, it offers it will give an offspring which is genetically identical. So this reproductive one, it gives offspring which are genetically identical to the parent or to the donor. So the offspring which have been given by reproductive one, they are genetically identical to the donor. With therapeutic one, it will produce stem cells which can be used for health, anything that deals with health. So this one therapeutic, it gives stem cells which can be used for health purpose. So this one is for health purpose, and then this one is for producing offspring which are genetically identical to the donor, which is this one. Genetically identical to the donor, it produces stem cells which can be used for health purposes. So that would be purpose of each. Two disadvantages of this process. Okay, it's expensive. First point, they're expensive, and then number two, they reduce genetic variation. So you can say it's expensive, and also it reduces genetic variation. And because it's a process, it requires skills. Whoever's doing it must be very good. They require a lot of good skills. So the three functions you can list here is that it's expensive, it requires good skills, and also it reduces genetic variation. Then now let's go to 4.4. So now here, diagram 1, primary cell, okay. Then primary germ cell, okay. So we're undergoing sperm cells are being formed, which is spermatogenesis there. And then here we're forming X, which will be oogenesis, okay. Identify the process in diagram 1. Diagram 1 is we're forming sperms. That will be spermatogenesis. 2, we're forming an egg, is oogenesis, because we're forming an egg. As long as you see an oocyte here, so it's oogenesis. You see spermatid, it's spermatogenesis. Labels A, B, and C. Okay, A is this guy here. That's A there. So we have to find the label of A. A is secondary spermatocyte. Remember here we've got primary spermatocyte here. Then here with this A, it becomes secondary spermatocyte. So A becomes secondary spermatocyte. That's A there. That is secondary spermatocyte. And then we go to B. Where are you B? Oh, B is this one. So B is sperm cells. Those are sperm cells there. Don't forget A is secondary spermatocyte there. Then B there will become sperm. Just from sperm cells. Just call them sperm cells. Now they've been formed as sperm cells. That will be where B is there. Then we go to C. C is this one. See here. Here it was primary spermatocyte. So meaning C here will become primary oocyte. So here it's primary spermatocyte. Here it becomes primary oocyte. Here is secondary oocyte. I feel like the other way you can also remember them. Here is primary spermatocyte. Here it's secondary oocyte, meaning here it will be secondary spermatocyte. Here is primary spermatocyte. Here it will become primary oocyte. The case gonna be like that if you remember them quickly in the exam room tomorrow. And then lastly, we did B and C. Yeah, we did B and C. That's fine. So meaning D will be the X cell name. D will be X cell. They didn't ask for it, but D will be X cell. Name the type of cell division that results in formation of C. To form C is this one. We are from the beginning. Here at the beginning we have got mitosis there. And then here we start having meiosis. So at the beginning there we've got mitosis. So it'll be mitosis. That's what you get at the beginning or at the top there. It's mitosis. And then you'll have meiosis at the end or towards the end. So there you've got mitosis. Then here you start having meiosis towards the end. Okay, 4.5. It is important for the farmer to observe the cow prior, during, and after pasteurization because this process can negatively be affected by many factors. Okay, give the term of that refers to birth difficulty in cows. We call that diastocia. It's called diastocia. We call that diastocia. It's called diastocia. It's called diastocia. Okay, it's the term that it calls difficulty in cows. Okay. There are two problems which are linked with the fetus that may interfere with the normal pathogenic process. So mostly the one that can affect that will be the dead fetus. If you've got dead fetus, that's a problem, number one. You can also have multiple birth occurring or having twins. Yeah, it's another factor that can lead to that. Also high birth weight. If the cow is overweight, can also influence that. So any three of those are fine. You can have a dead fetus as a problem. You can have high birth weight as a problem, or you can have multiple birth or twins as a problem. So any two is fine. And then 4.5.3, state two factors that may cause retention of the placenta. Okay, of course, old age. The more older you get, the body will start not functioning well. So old age can affect that. So old age can affect that. Also malnutrition. If you're not eating well, that can also affect that. Also disease can be a disease that will cause the placenta to come out. Can be disease, can be old age, can be malnutrition, it can be multiple birth, again having twins, because twins can affect your placenta. So any of the two should be fine. So let's go to this one. This is the last question. Yes, the last question now. So now the diagram below shows the order of a cow. Okay, so I've got labels A, B, and data. Okay. So again, we'll ask to label part A. So first thing first is to do part A. So part A is that part in the lungs there, which is the alveoli. So that'll be the alveoli. That part in the lungs will be the alveoli. That's the alveoli there in the lungs. It's the alveoli. So that part that you get in the lungs is just the alveoli. So that'll be that, the part that you get in the lungs. Then B, where are you? That's B there. B is a gland cavity. That's gland cavity. So B is gland cavity. So that'll be gland cavity. B is gland cavity, which will be there. That's B. B is gland cavity. So you'll have that as gland cavity. Okay. Indicate the letter that represents the part where milk is produced. Milk is produced there, which is A. So milk is produced at A, which you know is the alveoli. So that's A. So milk is produced in the A. Then 4.6.3, name the hormone that is responsible for each of the following functions. Synthesis of milk. Also, if you're doing life science, you will know that the master gland or the pituitary gland secrete the hormone prolactin. So if you're doing life science also, you will know that prolactin is produced by the master gland or the pituitary gland. So prolactin is for milk. That's the hormone for milk. Milk letdown process. The hormone that is produced there is oxytocin, which is also there in life science. If you do life science, I feel like these hormones will just be easy for you to remember them, because they're there also in life science syllabus. Oxytocin, the hormones which are used for that. So yeah, that covers that. So I've covered the whole paper, which is a good thing to say. So comment in the comment section if maybe something that doesn't make sense, and then maybe suggest which other papers you might want us to do to help you guys as you're writing Agric paper 1. And then I'll also check on the timeline or playlist for paper 2 as well, because I want to do paper 2 as well, so at least you guys can write both papers. I think you guys are writing them at 2, so hopefully you guys will write them well and don't do any problems with the weather, and have fun when you write them and enjoy them. And then for those who won't be doing a Greek after grade 12, make the most of the paper and then just do a good farewell to it, and then everything will go well. Thank you very much.